Hey there, everybody. Welcome to Houdini Hangout. Hope you're all doing well here in the end of July. Yeah, it was a busy week last week for me. Got to go up to SIGGRAPH, and that was fun. But yeah, now we're back here, and yeah, things are just kind of. Hello, everybody. Hey, Terry, Motion, Johan. Hey, Krista. Hello. Oh shoot, my audio. Hello. My music is not playing. Well, it's playing, but it's not coming through in the mix. And I'm gonna have to think about why that's the case. Oh, what's going on here? Oh, I bet you I know why. Ba, ba, ba. Interesting. I'm gonna have to think about that. Why that's not working. I updated my software, and I think it freaked everything out. But that's okay. That's what happens. Anyways, we'll be fine. No music in the background today. That's good. That'll be totally fine. Hey, Sepwin, Giodos. Hello, everybody. Hope you're all doing good. Yeah, so like I said, I was at SIGGRAPH last week. A lot of fun. Got to meet a bunch of people. No, I don't use OBS. I use a bunch of other things. But yes. Anyways, sorry, I've got a million screens here, and I don't want to see myself moving. Cool. No, I use Wirecast, and I use a couple other things for my audio to go back and forth between my computers. But anyways, not overly interesting for conversation here. But yeah. Anyways, yeah, last week was SIGGRAPH, super fun. A lot of people got to chat with a lot of people, meetings, things like that. Unfortunately, didn't get to go to a bunch of sessions. But that's kind of par for the course when you have when you have prior commitments outside of the actual meetings. But anything interesting at SIGGRAPH? I didn't particularly get to sit through anything all that interesting. I got to go to some stuff at DigiPro the day before, and that was cool. I don't know. I mean, the stuff that I did see was like, there's a lot of Avatar stuff in DigiPro. And so that was kind of cool. They're, obviously their Fire and Ash stuff. Actually, I haven't even seen that movie, but I don't think anything got spoiled from the videos. It's like, yeah, there's blue people running around and there's a lot of fire. So yeah, pretty standard for an Avatar movie. So that was kind of interesting. There's a couple people tried to do like, oh, cool. Hey, Procedural, how's it going? Yeah, so there was a couple of like presentations at DigiPro that were like kind of AI adjacent, and they were all really underwhelming, which was kind of funny, considering we've been at this for how many years, and like they were trying to do like scene layout stuff, and it was just kind of like, okay. And it wasn't like small. I can't remember the studio that it was, but was it? I can't remember what studio it was, but it certainly was like, you guys had enough resources to really do this if this is very possible right now. And they were doing like layout stuff with it, and like it was okay. It was like, I think I can do this faster, like by a multiple. So anyways, so that was kind of interesting. Yeah. Anyways, so yeah, SIGGRAPH, DigiPro. I got socks from DigiPro, which was weird swag, but that was kind of cool. And yeah, I got a new Houdini shirt here with the little dragon guy, so that's kind of fun. Yeah, anyways, so that was my last week. Now this week, back to the regular. I also won't be streaming next week because I'll be on vacation, so that'll be nice. But yeah, so hey, no dinosaurs. So this week, what I wanted to talk about was Houdini 22, which is funny because people at SIGGRAPH kept saying, "Oh yeah, Houdini 22 just came out," and I'm like thinking about, it, I'm like, did it? Oh yeah, I guess it did. Like, it's really weird to know about stuff ahead of time sometimes, and then it totally like breaks your perception of when something actually was released. So yeah, it's very and like the launch was a month ago, and so it's like, I don't know, all my time frames all just got mushed together apparently. But yeah, it only just released a couple weeks ago, which is cool. And today we're going to look at a few little topics that weren't super like covered in depth through the launch presentations and stuff like that, in the keynote and stuff like that. So I figured I'd go through a few different features, and we can kind of chat about them. And if you guys have features that you think that you don't remember seeing in the keynote presentation, and you'd like to go over it in the stream here, throw them in the chat. Happy to talk about them and stuff like that. I've got a little list of things. So if you do mention something, it might be on my list already. So, and I'm going to kind of go through them and just kind of talk about them and give some feedback on it and like things that I think are cool. Hopefully there'll be some little things in here that you'll be able to, hey K4, welcome. Hopefully there'll be some things in here that will help you, with workflow things. They're certainly not the big flashy features that got added, but they are little things here and there. So should be some interesting stuff to take a look at. On that note, if you guys have any questions or thoughts or comments or anything like that, feel free to throw those in the chat. Always happy to to stop and kind of clear something up if I'm not being describing something straightforward enough. If you think I'm doing something the wrong way, which I guess I could be. I'm not really going to be doing too much of that today. But, if there's something you're like, I think you can also do this way, feel free. Feel free to drop a correction in there if you think I'm off base. Other than that, that should be pretty much it. So why don't we jump over into Houdini and we can start playing around with some stuff. Yes, big dramatic fade. So Houdini 22, here we go. It's fun to finally be able to have it on the stream, so that's very exciting. So let's drop some geometry down here. I'm going to do just a geometry object, and this will just be for. Oops, I've got all of my notes or all of my. I've got all of my stuff up. So hold on one second here. I'm just gonna mute everything, please. And mute. There we go. Then I always forget to unmute stuff. And then I'm like, I'm doing stuff at work or something like that. I'm like, why is everything muted? Anyways, Motion Maddie said creating points on geo inside the CopNet and attributes. Oh yeah. That's another good one. Yeah. Attribute wires in Copernicus. Yeah, it's a little weird. Like, it's definitely, I'm not 100% sure even what to do with it per se. Hi, Mandy. Good morning. Wow. Good evening from me. Must be like middle of the night morning for you. All right. So anyways, let's talk a little bit about the geometry spreadsheet first, because I think this is one of the coolest updates to this whole thing. So the geometry spreadsheet, very cool. Well, actually, before we even get to that, the little nomen here has been changed. Nomen, whatever we call it. And we have these little spheres that actually snap to the directions, which I think is very, very fun and exciting. So yeah, it's kind of nice. You click it, let's see here. You click it again and you get out of it or whatever. I don't even know. I don't even know how I did that. Interesting. Oh, there we go. Yes, it's past midnight. So there you go. Early morning. So anyways, little kind of quality of life thing here with this this little floating gnomon here that you can click on. Gnomon, whatever. I keep saying it a bunch of different ways. So yeah, so that's fun. But the geometry spreadsheet is really, I think, one of the coolest things that got a lot of love in this version, basically. And so one thing that you'll notice, first of all, is that, and hopefully none of this stuff is like not working for some reason, but in past versions, if you were, say, adjusting something here, right? You're like, what's the name of this? Oh, okay, shop material path. Or you're like, I want to see this whole text here, right? Well, that would actually apply to the second column of all of the geometry spreadsheet. But now that shouldn't be the case. That will only apply to the primitives in this case. Same thing with any other, level of this. So if we do this here to read those, that's not going to affect anything else. And it should remember these for you. Now it'll remember it across the session. And obviously, I think if we do, let's just put down another null here. And maybe I'll go for the skeleton instead. Oh yeah, look at that. Didn't even, okay. So it actually is remembering it per node, oh, that's just so nice. It's just very nice. There's great stuff happening here. Anyways, and I believe you can double click on them and they will try to kind of like right size. There's also a right click now, and there's a bunch of stuff that you can do with this. So you can reset the size of them and a bunch of other stuff. So it's like there's so many things in here. It's almost hard to mention them all. I think there's a bunch of stuff in here, but mainly the stuff is happening here, right? So here you can see, different types of attributes, right? Here you can see we have, position attribute. This is a transform attribute, and it's a matrix. And you can see that we get different icons for all of these things. I think if we go back up here and visualize this, I think there's there's one for the UVs. So there's now all of these little custom icons for all of these different things. You can also reduce the size of these like pretty insane, like to a pretty small size. So you can do a lot of stuff with this, first of all. The other thing that you can do, which I found really interesting and might be something people find useful, is this flatten tuple. And so basically you can see here now, the position is one vector attribute now. So you can see here, you're seeing this all in one column. So if you have a ton of different vectors, this could be really, really useful to make things a little bit less overwhelming in the view. So now you can see here, we've got it that way, and we can expand them back out. I think if we come over here, let's see, are there any more that we'd see here? No, but yeah, so a couple of interesting things right there. I believe the way that these sortings work is slightly different now. No, okay. There were actually 3 versions of this, and I think that actually got nixed. But there was like a weird different thing that I noticed with that. But it looks like we can also come in here and do something like this. Like, let's say we wanted to do a visualizer on this. It looks like we can add so this will show the different named attributes from there, and we can turn that off, and now we can see the different named attributes. And that should actually, I bet, yep, that does also tick this little box on, so that's really nice. We can also see our different shot material paths here, although those are text right now. Athens was asking, did anything change for the geo spreadsheet in DOPS? That's a good question. I actually don't know the answer to that. Let's come in here. Actually, no, let me just do I'll just do a pop network, because that will give us some nodes here. I don't think so. I mean, obviously it's the same thing right here. But I don't think there's anything inherently different about it. Yeah, I don't think so. No. It's really all the same data that's being controlled in here. So, if you have any suggestions for that, I would certainly recommend throwing in an RFE if there's something you're like, man, I'd love to see it do this. Right. Still have to drill down to see the attributes. Yeah, because I mean, really the point with that is, the point of it being in here is that you can have multiple different, basically like pieces of data that can hold geometry, right? You can have all these different like data objects and stuff like that, and they can have geometry and all these things attached to them. So it would be weird to not be able to see this, basically, and that's kind of part of the idea here. Is you want to be able to actually see this, as well as being able to jump into the geometry here, because this is really just showing you more or less the SOP data inside of this, I'm pretty sure. Yeah. Oh, now you can decompose matrix in the spreadsheet. Yes. Yes, you can. I did see that. Where was that? Was that over here? No, I think it was here. Where was it? I did just see that. Where was that? Yeah, there it is. Decompose matrices. So yeah, you can see here, here's the actual matrices. So I guess that would be rotation and scale, I'm guessing is showing. Yeah, it's on the right. I knew I saw it somewhere. So that's kind of interesting. So you can see that as well. Full precision. You can up the precision there. That's actually also this little toggle. So you can see higher precision. I'm not sure what the typed dictionaries are. Oh, I think that means if you had a dictionary attribute, it would show what type it is or do something with that. Oh yeah, here's the matrix thing as well. It's right there. So you don't even have to go into this little gear. You can just do this. Now you get your transform, rotation, and scale. And these are all rotation and scale. There's no transform on those. So that's why you're seeing it that way. So yeah, either way, that can be really, really helpful. So this hopefully is just something to make things a little bit easier to see, you know, to kind of get a general sense of what's going on in your geometry spreadsheet. Also, I'm pretty sure that the color alternation here is actually based on the, like how many, like if you have your P attribute here, right, it actually keeps these all dark and then the next one's light and then dark and then light, so on and so forth. So the alternating colors in the columns, I believe, follows that. So you can see here, yeah, it looks like it's following that. Then the other thing that's kind of interesting with this geometry spreadsheet is if we, I'm going to do the USD create component. This was something that was shown in there, which was pretty, I think, very nice. But what we can do here is we could just say, I'm going to name this Cappy. We'll throw this in here. And let's do I mean, this is silly to do because obviously you have the test geometry, but let's grab the toy. I'm just going to do the same thing here, and we'll call this toy like so. So we've got Cappy, we've got the toy, and then maybe we'll do another one here. I don't know, do Tommy. Make a copy here. And you'll see in a second why I'm doing it this way. So we have these create component things now. And so the idea here is that, hey, Philip, hello, how's it going? So the idea here is that we have, basically the way that these create components work is it's actually doing some like packed folder work behind the scenes. And so that is actually how these create components are working. And if we were to say, merge these all together, we would have 3 different components here, right? And so what you might think like, well, how can I see this? I think they may have shown this in the other fine and sleepy. Yeah, it's late for you guys. So what we're doing here is we're actually packing these into folders. And so you can see here that we now have this kind of packed folder structure that's basically saying, okay, here's the geometry inside of this, right? So we've got Cappy geometry, we've got the toy geometry and Tommy geometry. And so these are all getting packed into folders. And you can see that we can actually like kind of inspect the entire hierarchy that's going on here. So we're getting this series of packed folders coming into this one basically stream of geometry. And so this is how Solaris knows how to interpret what we're doing over here. And you'll see if we did this as well, I think there's a proxy, yeah, USD create proxy geometry. So we can just do this and make some proxy geometry. Let's say convex hull, and we'll just throw that into the proxy geo. And we'll just do that for each of these for kicks. And what we'll see here is that we're going to get, now we should have proxy geometry under each of these. So if we open up geo, we're going to have render and proxy, and we can see here we have different geometry for each of those. And yeah, so this is the idea of kind of how this geometry spreadsheet can actually be super useful when you're trying to investigate what's going to happen as you go over to Solaris. And so if we just did a null here and we said out components, and then we did a LOP network. I mean, this is obviously a mishmash of networks now, but we'll just say Solaris. We can jump inside of here, do a SOP import, and let's just locate that out components. There we go. And you can see here now we've got all of these components in here. I can also say, I can also say don't have an import path prefix because we already are kind of setting up our components here. So now we can just set them up that way. And so the other thing we can say is say, just don't do any authoring here. We could just say, we'll put this under geometry, right? And there we go. Cappy Tommy Toy, all there. And if we change it to our final render, we'll see all of our final geometry, although that looks horrific, but there you go. So this is showing you how, you know, sort of how that would work. And another thing too that's actually not correct here is that these should all be set. This should not be a transform. This should be a group. Huh, interesting. I'm surprised by that. Well, I guess you'd have to fix that because that is, that would not be correct. Oh, cool. Great, Solus. I'm glad that was helpful for you. Well, we're going to go over a little Pyroblock 2.0 in a little bit. So that might be old news for you, but yeah, anyways, so this is an easy way to be able to import this, just kind of sneaking in a little of this USD create component in here. But you can also see how these things are structured and how they work. You can turn that little folder view on or off there. So anyways, really nice to be able to kind of see the hierarchy of your packed folders, things like that. And hopefully maybe there'll even be some more updates on this in the future, because I think it's really nice to have some new features in the geometry spreadsheet. So anyways, that is a little touch on that specific thing there. That's touching on the geometry spreadsheet. So the next thing that I wanted to talk about was the follow parent context button. And for this, I'm going to grab I think I'm going to grab a LOP network here. And we're just going to say follow. Any plans on adding UDIM support to Paint 3D in Cops? I wouldn't be able to comment on that specifically, but I would expect that, I mean, UDIM support is something that we want to have as ubiquitous as we can in Cops. I think a lot of times the easiest first pass on something is to not have UDIM support, just because that adds so much kind of overhead to probably all the code path and stuff like that. So I'm guessing yes, but I don't know, and I wouldn't be able to comment if I did know anyways, but I have literally no idea. So, but that would be my 2 cents on everything. Like I said there, I think you'll find, I think you'll find more UDIM support as the versions go on. So, cool. Okay, so let's talk about this follow parent context. So, let's just grab something that doesn't have a texture on it. This one doesn't have a texture on it. So let's do this. So we've got our template head here. We're just gonna use that as a test geometry. And then there is the texture material library, which I think is the one I want to use. So what I should be able to do here is have a USD material here that I'm going to make from Copernicus, right? And so I'm just going to call this my material. We'll jump up a level here. You can see that this is now my material. It's under materials. And let's just assign this right here. Interesting. I don't import geoprims. Not sure what that would be. Anyways, let's just apply this to the whole head. That should be fine. Okay, so now we're applying materials there. Hey, Anya, how's it going? Didn't realize that you were saying that to everyone eating dinner while watching. Nice. I have to usually eat my dinner just before I go on the stream here. Okay, so this texture material library. Oh, interesting. Oh, that's fascinating. Okay, that's really cool. Well, there's a cool hidden feature that I didn't even know about. So apparently this button right here will import the geoprims into your texture material library here. And now it's available as in Copernicus. But that's not what we're here for, but that's really cool. So just to show that again, click here, we should get that little node. And now this loads and unpacks the geometry. So now we have that. So cool. Okay. Anyways, let's just throw in some noises here. Let's use one of the new ones, curl noise, maybe. I don't know. That's our base color. That's a weird one. Let's see here. Always new noises, right? I always like the phaser noise. I think that's pretty fun looking. And let's do a mono to RGB. And then let's put this into the base color. We should see, yep, now we're getting this on our actual template head, right? And let's just say we were using our Karma physical sky here to light this. And let's up the exposure a little bit. I feel like we always need to do that. And then let's just say we were rendering here, right? And it's like, oh, great. There's our head with the weird phaser noise on it and all that stuff. But if you were going to do this and you wanted to keep editing this, you'd jump into your texture material library and then you're back to basically a Copernicus viewer, right? We're viewing our Copernicus network. And so this is not really what we wanted to do. So what we can do is we can come up to, normally what we would have done in the past is we would have had to do this kind of convoluted process with pinning and all that kind of stuff. But now if you right click on this and say display as pane button, we should get this little, you can see here, this is the follow parent context. You can enable it or display it as a pane button. I find it to be helpful to have it as the pane button, but I think you have to save your, holy cow, my desktop, with this, button out. So now if we click this, we should be back into, Solaris, right? But we're still able to work on everything else basically as if we're in Copernicus. So now just our scene view is going to be following this. We can uncheck that and go back into it as well if we'd like to. But now we have this and we can say, okay, let's take a look at this. And I don't know, maybe we'll do Inferno for this. And now we've got some Inferno color on this, something like that. And if I don't know, let's just even put like a blur here or something. So we can kind of go through and tweak this and, yeah, so there we go. Maybe we give it a little softer edge or something. I don't know. There's probably other ways to do this, but yeah, so we've got that, and we could always change the element size and tweak this and stuff like that. So the really nice thing about this is that obviously we're have access to all of the Hey Chris, how's it going? Everyone say hi to Chris. He's from Side Effects, and he did a lot of really great work on this last release of Houdini. So there you go. Oh, Ammon is saying, at any point, I'd love to know how to use adjacency for seamless. Hi, Chris. I'd love to know how to use adjacency for seamless UV with regular noises, grunges. So far, I can only get to work with 3D noises. Yeah, I haven't actually played with that yet, but I'm going to have to get into that at some point soon. And I'm also working on like a course for some Copernicus stuff. So hopefully that'll be coming out not too long from now. I don't know. Still have to record it and everything. But anyways, yeah, that's a little bit beyond what I'll be talking about today. But certainly that's, yeah, the adjacency stuff is really helpful. It's just, yeah, you've got to kind of understand a little bit of what is going on with it. And obviously here, right, we're not getting that, we're getting those seams as well. And cool, I'll sign up. This is very cool. So anyways, so yeah, so this follow parent context is nice because obviously it gives you the ability to kind of keep track of what, there you go. Yeah, Chris did a lot of the scattering stuff in Solaris. So it was Chris actually asked me to help with some of it, testing and things like that, which was very nice, but he did all the hard work and I just poked at things and said, this doesn't seem to be working right. That's pretty much it. Anyways, so yeah, so this is really nice to be able to have, your viewport in Solaris while you're working at Copernicus. We can do all sorts of things here, right? So we could do, I don't know, we could do something like, let's throw something else in here. Another noise. Maybe we'll do crystal noise because that's going to be pretty obvious. And let's say we did the metalness with that, something like that. I don't know. So the one thing that will take a minute here is that obviously we have to compile our. That's true. There's lots of people involved, but yes, Chris is part of a larger team. There's lots of other people there too, but they don't come in my chat, Chris. So they don't get credit here. So just kidding. Yeah, you got to watch the names at the end of the credit there, and then you'll see all of the awesome people that get to work on this stuff. It's very cool. It's very humbling for me to be like able to be a little part of it. So actually, I'm using this probably in the dumbest spot possible. Maybe we'll throw this in the roughness. Let's see here. Yeah, maybe I'm just using a bad example here. Let's pick a different one. Oh, you know what? I'm just going to use like checkerboard or something simple. Something like this. And we should be able to see, guessing our specular roughness. Oh yeah, that's right. If I turn this up, that'll probably help. And then, let's see. What am I doing here? This is going great. Color. Let's grab the black color. There we go. Now we're actually seeing this, but anyways, so, can you show the adjacency stuff on this example? You know, I haven't really looked into the adjacency stuff too much. So, I'm trying to think. So what we would have to do maybe here is grab this. Why am I actually seeing that? Oh, because it's looking at the parent context still. That's funny. That is really funny. So yeah, be mindful of this little button. It can get you into some trouble, but if you just keep it on. All right, so I'm actually going to look at this here now, and we're going to see this node, geometry to adjacency. That should work. Now we should be, okay, thank you. Should make an adjacency map. And what does this... Oh, there you go. Materials in USD are containers. Yeah. There you go. Getting a lot of good information here. And yeah, definitely inside the mind. Yeah, check out their thing. If they have a video on it, I'm not even going to bother with it here because I'm just going to be poking around and fumbling around. So yeah, take a look at it. The adjacency stuff is definitely cool. I'm not gonna get into all of that stuff right now. Because we did talk about that a little bit in the thing. So anyways, there's our little button. So that's some of the UI stuff right there. Cool. So follow parent context. Nice little button to have access to. Another thing that I wanted to talk about was implicit surfaces, because those were sort of touched on, but not too far. I think they just kind of mentioned it and was like, that was pretty much it. So let's take a look at what they are. And to be honest, I haven't worked with them too much, but they're pretty straightforward how they work. So let's go hide the other stuff here. So we can create an implicit surface here, right? So here is our implicit surface, right? And it's a box. And so basically what we're doing here is we're creating more or less a formula to create this object, right? So these are like mathematical functions that define certain simple geometric shapes. So you can see here we've got a box, a plane, a sphere. So here's a sphere, right? We could do an empty one, I guess. We could do a torus, stuff like that. And so what we could do is we should be able to grab another one here, say, yeah, like a box, for example. And let's just move this a little bit around. Oops, grabbed the wrong thing. There we go. And so we have two different implicit surfaces here. And what we can do is, I believe we can do an implicit surface operation here. We should be able to take two different implicit surfaces and then do some mixing together here, right? So we can union these two surfaces together, and now we have one kind of implicit surface between them. We can also do some smoothing, I think, as well. And so we should be able to do that. Let's see here. Why is that not working? That's interesting. I thought that would work. Um, Weird. Huh. That's kind of fun. You can turn it into a link. It's kind of cool. Why is this? Sorry. Don't know why this is not working the way I was expecting it to. Yep. So the difference between these implicit surfaces and regular geometry is that they are they're basically they're kind of like an SDF in a way, but they're like a mathematical representation of like what an SDF is. It's basically defining the surface of geometry with math versus trying to use a voxel grid to define where the surface is crossing, basically, with like an SDF in that case. So I'm not sure why this is not working here. It's very strange. Oh, what's the difference between that and NURBS? I actually don't know that much about NURBS, to be honest. I think NURBS can be kind of modified with like things like Bezier curves and handles and things like that. So yeah. Sorry. So let me just show the implementation of this first, because I don't know why this isn't working here. I'm not sure why I'm... Yeah, I'm not sure why this isn't... Very odd. I feel like these should be going together. Anyways, it should be smoothing like an SDF, I thought. So that's really strange. Anyways, all right. So where you would see this is in Copernicus. So I'm just going to throw it on a COP network here, and we're going to go inside of this, and I'm going to do a pyro configure. Let's just do the billowy smoke one. That's fine. So let's just compile for a second. Oh, does it need the evaluate node after? Maybe. I don't think so, but maybe. It's a good point. Sorry, compiling. There we go. Yeah, let me just see here. Oh, maybe. Yep. There's the answer. So it apparently can't visualize it like this. There's the answer. So we need to convert it to something else. So we could do implicit to mesh. Let's do something a little bit bigger here. Okay. Now we're working. Now things are working. So what you can see here that we're getting is basically this is doing a mathematical calculation of this. and we can just smooth this out however we want to. It's incredible. It's like way faster than doing this with a VDB, right? There's no math or anything like that has to happen. There's no conversion to a VDB and then doing the smoothing and then back and forth and all that kind of stuff. It's basically, we're doing all this implicit surface work here. Let me see here. We could do intersect. There we go. That's what I was missing. So here, we could subtract this from it. We've got that. We can also smooth it out then, right? And this is, again, just a mathematical representation of what's actually being intersected between these and some smoothing that's happening. And then we can convert this to, whatever we might want to use here. And so we could turn this into a mesh if we wanted to. It's sort of like a meta ball, but it's like has other shapes involved in it. But yeah, it feels like a meta ball. But anyway, so it's this really interesting kind of way of being able to kind of hack things together. I think if you saw that like guy with the wacky hair and he kind of is like a sphere with like a couple tube arms coming off of him, I think that was all modeled just using implicit surfaces to do the modeling. So it's kind of like a mathematical version of like VDB modeling in a way, where you can do all the smoothing and that kind of stuff, but doesn't quite have the memory overhead and that type of stuff. It's much more efficient in those ways. So anyways, okay, there we go. Now we're actually seeing this work. CG Fort. Yes, it is the bee's knees. They're very cool. So it looks like prep H is needed. So what we can use here is now when we come inside of Copernicus, because this is all sort of GPU accelerated and things like that, using our implicit surfaces are kind of really important, because the Pyro source shape is going to use these implicit surfaces internally to create them, right? So if we go inside of our SOP geometry here, there's actually some implicit surfaces being created in here. So so what we can use is we could let's see here. So what we're looking for in these, like if we wanted the collision geometry on this, we did collision, we should be able to import an implicit surface and do that. So for example, if we wanted to do this here, we could do a couple different things. Let's say, let me put this on the bottom first of all. So let's just move this down. We should see that we're going to get this. Yep, there we go. Some sort of weird type shape here is happening. And let's extend that like so. Cool. I don't know. Weird shape. Anyways, let's do a null here, and we'll just say collider. Actually, I don't think we even want to convert it into anything. I think we can just use it as is. Yes, I think there is a way to do that. I think. No, sorry. I don't think you can actually, because the whole point of them is that they use, it's just a mathematical function to define this surface basically. And so I don't think there's a way to really make a mathematical function that would just arbitrarily, toilet seats on the way. I don't think there's a way you could arbitrarily make a formula in this way, or at least it would be, I don't know. I'm not sure of all the math constraints behind it, but I don't think that is supported to do custom surfaces into implicit. So yeah, I think if you're doing that, you'd want to use a VDB instead, probably. But anyways, what this could be useful for, let's do just a transform here. Throw this in here, and let's move it up. And we should be able to see, there's where that is. Okay, cool. Let's just put that, I don't know, maybe there. And then we'll do a SOP geometry here, and we'll use an external path, and we'll find this collider right here. Accept that, throw that in here. And so give this a second here and let's hit play. And what is our shape that we're dealing with here? Let me just see here. Maybe I'm thinking about how this is working not properly. Oh, okay. You can convert some geometries to implicits via implicit surface convert. There you go. Interesting. Pyro collision shape. So, okay. So maybe this would do it. Maybe this is going to do what we want. Try that. It'd be cool to have it resolve NURBS. Oh man, NURBS. Yeah, there we go. That's doing it. Okay, so it looks like what you want to do is use your pyro collision shape, and you can input an implicit surface in the front of it. I knew there was a way that would work, and so then that must convert it over into the correct, information. Basically, it changes it over into something. Let's see, pack geometry free points. What is that? Okay, so basically, this is now done some conversion to the implicit surfaces to be able to use them here. So now you can see this is going to come up and it's going to collide with that shape. There we go. And so this is just going to make a much, just an effective collision geometry basically for us here. So there you go. So now you can see we've got our collider that's pushing this and we're getting some interaction there. I could have obviously made a little bit of a better collider for it, but in fact what we could do here is maybe add some more turbulence into this here, and we'll see if we can get, yeah, there we go, a little bit more turbulence around it. There we go. Now you can see our collider here, our kind of weird torus, flat torus thing going on. Gives a little sense of what we're seeing there. But anyways, so there we go. There is our implicit surface work. So basically these surfaces are going to be a little bit more efficient for things like this, where you're doing emitters and things like that in Copernicus, using these newer pyro tools and things like that. Oh, cool. I didn't know that Substance Modeler uses implicits in SDFs for modeling. Cool. That's very cool. I did not even know that detail. Cool. So there we go. Hopefully that gives you a little sense of what these implicit surfaces are. You can convert them to be able to be used for other things, right? So you can see kind of what's happening with them. You can obviously do some of these smooth maths to it and things like that, or just leave it as is. But in order to see these, obviously we need to kind of convert them into something else that can actually, kind of display this. In this case, we're seeing it as a mesh. We can also change it to a VDB. We can do a bunch of different stuff here to kind of convert this. Thanks, Leonard. So there we go. Sorry. Someone's not happy. I think someone's moving by. Okay. Sorry. No Leonard appearance this time. Everyone says hi, Leonard. There was a dog. apparently that's against the rules. Okay. Anyways, so we've got, let's see, we've got our implicit surfaces here. So let's jump back inside of this cop neck and just say, I'm going to say pirate block 2.2. So let's jump in here and take a look at this real quick. So if you remember in the last version, we did not have, let's see, I'm going to change this over to, I'm just going to do this. There actually was a bug at some point before release where if you did this and then worked, it would actually crash your Houdini session. So if you ever run into that, please let us know, but I'm pretty sure it's solved at this point, but it was very annoying for me for a while trying to make Copernicus content. Anyways, so this block is a little bit different than the way that it was last time. If you remember the last version that came out, in 21, you had to do all of your work inside of it here. Now we have this really nice, block setup where we basically have our cable that's going between these here. We have this kind of override input here, or input override. And this is basically passing all of these different fields between these two blocks. So obviously it's looping over these, but it only has one connection because it's passing density, temperature, velocity, flame, divergence, collision, and collision V all through this here. You can obviously do some more work down here if you want to. For example, you could put in a cable to pass into here, and then you could have some other feedback happening in a loop in here. But with this in mind, we don't really have to add any little microsolver type things in there. Now, we never really had the true microsolvers like existed in DOPS. But if we do, for example, we do pyro, let's see. Just trying to think if there's one that would be a good one to show. We could probably grab the buoyancy here. And so we would be able to actually affect this, right? So we could actually come in here and wire these things up the way we wanted them to. So like we'd have to grab velocity and temperature. I don't think any of these, maybe you've had like a threshold field or something. Let me pull up the thing here. But what we would do here is we'd need to actually like take this. If we wanted to add more buoyancy into this, we should be able to by... let's see here. So what I should be able to do is, let's see. So I should be able to do this. And so now that's going to technically overwrite it. I should be able to do an add in here. And we should be able to do, this is the foreground, this velocity is the background, and then blend these both into here. So now we have some more, we should have more buoyancy that we're able to add into this. So let's see if we do. Yep. And sure enough, it's going infinitely too fast. It's just flying upwards and it's absolutely losing its mind because of how fast this is actually moving. So let's just go back here and actually, instead of adding in a bunch there, let's actually add in some negative and let's see if we can slow it down a little. Nope, but we can make it go negative. That's cool. Oh, okay. So here's what we could actually do. We don't even need to do that. We could just wire it in like this because this is actually doing the add itself. I missed that somehow. So let's just do one here. And that should work because I think we were doing like a double add or some goofy thing there. So now you can see that the buoyancy is going way, way faster. It's flying upwards. It's kind of ridiculous, but there is our extra buoyancy. So we could come in here and add in our own scales, right? We could also take this instead, get rid of that. And we could do something like, we could just add some like, I don't know, fractal noise 3D and just, let's see here. I think if we did vector VDB there, we should be able to do that. And I think if we just did an add here, like so, should be able to put some noise in here. And I think I'm going to turn this like way down, just see if we can get some, yep. And there you go. You can see we're actually adding the noise in here. And we can do whatever with this, right? So now we're adding our noise into it. Maybe I need to have a position in there, but anyways. Yeah, I think I'm missing something here, but anyways, what you can see here is you can still add things in the middle, but if we don't have things in the middle here, everything is kind of controlled by this pyro block end. And so with this, we have all of kind of the settings that you would expect. Here we've got, buoyancy, disturbance, turbulence, sourcing, what fields we're actually working with, all this kind of stuff. I actually did a short video on this, kind of talking a little bit about some of these things and about the new pyro configure recipes. So take a look at that. You can kind of get a sense for that on the side effects, probably in the YouTube channel or somewhere, maybe in the tutorial section. So those should be up there as well. There's a question here that says, can the implicit surfaces be animated? Yeah, I don't see why you couldn't have them animated. Yeah, so you should be able to just say here, yep. Let's do $F. I don't know, ×3, something like that. Just want to see what this is actually going to look like here. Oh, right. Should have done it in X. My bad. Well, let's just delete the channels there. Whatever. I'm just going to paste this here. Cool. So does seem a bit slow, interestingly. I don't know if I'm visualizing something somewhere that is making this slow. Yeah, I must have been. Okay, there we go. Weird. Yeah, I must have been visualizing something somewhere. Okay, so there we go. We've got that. There is our weird surface that we've got going on. And so now if we come into our pyro block here and just hit play. Looks like we're animating this. Yeah. Looks like it's working. So yeah, it does work. A little weird, but it does work. So there we go. A little animation on it. So there we go. Yeah, so that is kind of a couple different things with the implicit surfaces, Pyro Block 2, all kind of improvements to the Pyro workflow in Copernicus, but also some new modeling tricks that you can do in SOPs as well. So there you go, implicit surfaces. And I'll just say Pyro 2. Cool. All right. So with that in mind, let's just hide these things. What was the next thing I had on my list here of cool things? All right, so let's get into some Solaris stuff. Let's do that. Let's do another LOP network here. And we're going to call this, oops. Mandy's just saying, it's so crazy. I actually didn't expect Cops Pyro to be 3D Pyro. I thought it was like Pyro for textures. Yeah, I mean, sorry, let's just go back to that just for a second, because that is a good point. Just remember, we are doing 3D Pyro here, but then what do we do with it from the after that? And what we do with that is we can actually rasterize it, right? So we can come here, hit rasterize volume. Sorry, just compiling this because it's first time I hit this. So what this is going to do is now turn this 3D volume into a 2D volume. So this is a volumetric rasterizer, and it's going to be flattening this for us into a 2D grid, basically. So there you go. And you can see here we have ambient light that we can control. We can change the exposure on it and such. And if we do RGBA to RGB, here we can actually see kind of the window of this. I'll undo the pre-multiply. And this is based on the camera as well. So you can see here we're getting this volume. moving. And if we do this to the camera, we should see that we have our camera in this position. This is another thing actually that's kind of interesting. We have cameras in Copernicus now, and in SOPs and a bunch of other places. So now kind of we have all of these different camera abilities now. So kind of every context you're in, you should be able to have a camera that you can control. So let me just come in here and actually say the rotate. Can I rotate this? Pivot translate. Let me think on this here. Can I move the pivot like so? No. Okay. Sorry, I'm not thinking about this correctly. All right, so let's just move this 90 degrees like this, and we'll just change the translation on this to be weird. Okay, so let's look through this camera. I'll lock it, and let's look at this. And I'm just going to move it to this side here. Cool. We'll just move it here. Now we have this camera. I'll unlock it. There we go. So now we have our camera here, and let's see. Now we should be able to visualize this. Lop cameras into Copernicus. Wow. Yeah, I haven't tried that one yet. Okay. So one interesting thing to note with these cameras is that when you rasterize things, it will actually rasterize it to kind of the position of this plane. So what you need to do is imaging distance here. That's what this is. And so if you want to control where that's going, you can adjust that like so. So there we go. There's the flattened version of it. And you can see here that there's our volume, right? And then here's our RGB version of it, right? So now we should see this from this side and actually maybe see some of those details that are getting like pushed around. There we go. So cool. All right. Anyways, so yeah, so we're rasterizing this volume into a two-dimensional representation of it, right? So that's some of the benefit that can be done with these Copernicus simulations. I think, so Mandy was asking, what's the advantage of these? Speed is one of the advantages. These are all GPU accelerated, so they're going to be a bit quicker than standard Pyro. And what you'd be able to do with it instead would be, maybe you could even use these for like background elements, you know, in a shot. I mean, you can use them for hero elements as well, but like if you wanted to do, if you're in the compositing world too, right? Like you want to have a bunch of little cards that can get composite in the back, but actually have real simulations. This is a way that some of those things could be done, more efficiently than doing a bunch of simulations for them and, maybe having to do larger scale simulations and scatter them around in your scene. So it's just an option for how you could do stuff like that. Yeah, I think there's pros and cons, right, to each option. There's going to be less customization that you can do in here, but you get the speed benefits from that. Basically, a lot of customers were asking for faster GPU style, type render, simulation for Pyro. And so this was kind of the answer to that, was like, okay, let's do this in Copernicus. It seems like it's kind of a GPU accelerated platform in general. And so, yeah, that's kind of the idea. And this is just the ambient light in kind of the scene. You can also do, I think there's another, you can do light from points as well. So you could actually have points in here and light the scene from, I think from different, you could basically set up directional light types and things like that in here. So there's a few things you can do here. You can also do scattering. So like if you had pyro, explosions and things like that, you'll see that those get a pyro light. And again, if you want to have a little quick start for this stuff, I did make a video on Side Effects website, so you can check that out. And I go a little bit maybe more in depth than I'm really doing here, and being a little bit more, I don't know, I'm following a little bit more of a script than just kind of off the top of my head. So, yeah, so then Maitland is saying you can bring cop pyro to full pyro 2. Yeah, I mean, I guess you could. I mean, when you output from here, right, what you're doing is you're outputting these VDBs, right? So these are all VDBs, and you can see now this is a little little new feature, I guess, too. These ports actually aren't just dots anymore. They have actual like types for them. So different types get different little dots here. So you can see these are like kind of our little clouds. They're little VDBs. And so that that there allows you to actually export this, right? This could be, you know, you could visualize this. And so from here, if we like click on this, we can see that this is a density float VDB. It's got certain voxel count and resolution. Like it's all very much what you'd expect from a VDB. And I think we could do, yeah, I think you could do this VDB to geometry, and we could just say the density VDB. And there we go for that. And yeah, now you have a VDB volume from this. Now this is technically geometry. I mean, it looks like you could actually wire in a couple of these too. So that's kind of interesting. So there we go. So now we've got density, temperature, velocity, and we could output this here. And so now these are coming out, and you've got a density, temperature, and velocity field, right? So obviously we're viewing all of those simultaneously, so we wouldn't necessarily want to see them all, but now you could do stuff with them if you wanted to. You wouldn't really have this go into a pyro simulation, I don't think, but it does work as far as like the output goes. And I think you could do, what is it? Bake volume? Sorry, I've got a hair in my eye. Ooh, that's fun. Could we do this? Yes. And we could change these. Yeah, there we go. So, I mean, technically you can use this to make, you know, to like mess with this and do all sorts of stuff, right? So you could take this, and now you've got volumes just like you normally would, right? There's not really anything different from it except that you simulated it in Copernicus. So, you know, this is a way that you can get your volume visualization as well. There is also a visualization in here too. You can do VDB visualize here, and then you can wire in like your density and all that kind of stuff. And then you've got these things here as well. So you can up the density scale and change the color here. So we could do this. No, you'd need input on that. Yeah. So, so really the easier way of doing it is actually putting it out into SOPs from here, right? But this is kind of just a GPU accelerated Matt Gray. So there's lots of different ways you can do this stuff, right? Obviously. Yeah, so I don't actually think we can do an output from here because it doesn't have any on it because we didn't set this up as a sub network, I think. So I think what we would, oh yeah, that's right. You can do this as your 3D output. So you can keep that on, and then you can change your visualize in here. And this should always now, let's see, like if I went up here and change the display flag, we should still get that same data output there. Yep. So the 3D output, we can lock it here to this VDB from Geo. We could even do a null here and just say out VDB Geo. Put our 3D flag there, and there we go. So anyways, yeah. So that is more or less how that would work. Yeah. So cool. Hopefully that all made sense. I don't see anything else here. Oh, so now we can create masks. This was something that Cosmotion97 asked. So now we can create masks in Cop Lake to create masks for reveal effects, growth effects, infections. Yeah, you certainly could. Yeah, as long as you're trying to do that along like there's probably a bunch of different ways you could do it. But yeah, you certainly could. There's kind of that type of infection type simulation stuff. So if you wanted to work, basically, if you want to work in texture space, that's usually what you would do for in Copernicus now, right? Whereas if you're trying to work more in 3D space, there's probably other solvers that would be better suited for that. But if you're looking for like reaction diffusion or something like that, or one of the other kind of interesting effects that they showed in the release videos, that you would take a look at that. Cool. Okay, great. All right. Hopefully that makes sense and kind of gets you understanding that. So maybe while we're in Pyro World, we should talk about one more thing here. So let's do this. Sorry, I want to do a comp network here. So let's do this, and let's say Copernicus time. All right. Changing my mind on how the order of things we're going to do here. So let's come in here. Let's do a Pyro configure, and let's do a fireball. That seems fun. So this has a slightly different rasterization step at the end of it. Give us a second to... and he was asking, I don't know if this was mentioned at any point, but was there a strong focus on Copernicus for this update? Oh, by the way, it's Copernicus with an O at the beginning, not with an A. Just FYI. Not that I'm not good at spelling, so I just happen to know that, but I normally would not nitpick things, but just wanted to let you know. It's like the astronomer. Okay, anyways. Yes, there was definitely a focus on it here, but mostly because it came out did it come out 2 versions ago? It did come out 2 versions ago. Yeah, it's just something that we've been putting a lot of time and effort into just because it's a newer context and people really like it. There's lots of stuff that we want to add to it, and we want to make a really solid platform for creating texture synthesis type stuff. And moving forward, doing more... No cap. Yeah, exactly. So yes. So let's see. I meant to say is creating the mask and cop. Oh man, that is a lot of complicated stuff. I'd have to think about that one. That's probably that would probably be a good thing to ask on the Discord server, because that's I'd have to really like sit down and look at that rather than just like try to process that right here on the fly. But I mean, you can definitely pass things back and forth from Copernicus to SOPs and back. Just remember that each time you do that, you're gonna be incurring a little bit of like that memory kind of movement hit that you get when you're moving data from GPU to CPU. So you probably are going to get that hit a lot in there. So the speed might not be the lightning fast thing that you would be expecting, but certainly if you'd like to, if you want to ask that question on the Discord server, because that might be a better place to kind of have a chat about that, you can go to houdinihangout.com. You can grab a, no cap. That is good. I like that. Yeah, grab invite to the Discord server, and you'd be able to get on that way through the link. And yeah, it's open to anybody. If you're interested, just go to the website, grab that invite, and that's all you need. Great. So yeah, maybe that'd be a good place to chat about that a little bit more, and then we can play around with. We can kind of talk about that a little bit more. Okay, so we have our rasterized, or we have our explosion here going. Great. There's our little fireball. Now, the one thing that is different about the way that these are created is that these explosions and things like that don't have our pyro burst source for them. And so with that in mind, the way that we source them is a little bit different because we don't have that kind of custom shape. We're using in order to get the speed, we're using just spheres, basically animated spheres to get that. And so that is what is actually making that happen. We also have a collision shape for the ground here. And what I'm going to do is I'm just going to adjust this camera a little bit. I'm going to move it a little bit in this space here. Let's see. Maybe like so and like so. And then we can just come down here and say imaging distance is 55. And there we go. Just move that a little bit closer because I don't need it to be as zoomed out. So, all right. So we have this rasterized volume here. I'm also going to change this as an RGBA to RGB. Let's throw that in there. And so now we should have our nice image. And I'm going to remove the pre-multiplication. There we go. And one thing to note here is that we have this light scatter. And basically what that's doing is using our density and emission, which our emission is our temperature. And so this is basically making this emission volume for us, basically. And then we're adding some ambient lighting to this, which you can't really visualize this until you get to the actual rasterization. So just something kind of interesting to note here is that obviously this is our ambient light. And so we can adjust that. We can also adjust this light scatter. And you can see here we've got our, how much absorption we're going to be seeing here. So maybe you can add a little bit more in there if you wanted to, right? So there's all sorts of stuff that you can kind of add to this, but that's not the most important thing that we want to talk about here. Let's come over to this RGB output. I think this is just nice because it kind of gives us this kind of final image. And in fact, I'm going to change this camera to be, let's just do like 1024 squared or something, maybe. It doesn't need to be actually that big. Let's do 512 squared. I think that'll be fine. 512. I just want to see if this is, yeah, those are going to be 512. Because what we're going to do is make a little like sort of flip book of this. In fact, I'm going to make this even a little closer. Let's say 45, maybe 40. Do the imaging distance like that too. Let's see here. There we go. Nah, it can be even closer. Let's say 30. There we go. And this can be at 30 as well. And then, yep, there we go. Fireball. Cool. Okay, so there's our fireball. What we can do now is we can actually get into some of our time stuff. There's a few different things that we can do here. We can do time shift, time pack, time loop, time blend. So time shift is obviously what you would expect it to be, right? Like you would take in your source here, and then you would say, we could just delete these channels here, and we would just say maybe from 24 to 1. I think that should work. Yep, it's going to simulate to 24. And now we have our time shift to 1. And yeah. And that should work. And then it'll play from there, obviously. I think you can maybe say clamp to both. Will that remove the time dependency? No, that's interesting. Yeah, maybe this is what I need to do here. I just need to delete these channels, then just say 1. Yep, I bet you that'll do it. I bet you that'll keep it. No? Okay, interesting. Yeah, that's not doing it now. Weird. Well, there should be a way to do this, but I'm not realizing it right now, and that's okay. It's a time shift. We're not reinventing the wheel. The one thing I think that's really cool though, since Houdini 22, I'm doing compositing in Houdini itself. Cosmotion 97 saying this. Yeah, I mean, we're starting to get to the compositing side of things. I think definitely there's going to be more in that regard needed. It's definitely not there yet. I think we've said that publicly a few times that, we're tackling the image synthesis or the texture synthesis first, and then we'll get into that. All right, so let's do this time pack. And this is, I think, the really cool part of this. So we have our RGB image here. What I'm going to do is I'm going to plug this into the source. And so what we're going to do is we're going to pack these images basically into a cable. And this is going to make a nice sequence of images basically that all reference from this original animation. And so we're going to have a range here that we're going to be able to set up. And so I'm going to just say like range is 1 to 64 maybe. So we'll do that. It's got to simulate it, obviously. So now this is actually packing that time into this cable. And so we'll let it do its simulation little step here. And there we go. And so now you can see this actually is the cable of all these different images. So the sequence of images basically. So just imagine this time packing almost as like creating an image sequence for you, right? And so you're able to have a whole sequence of these images. And we can add, let's see here, time. No, that's what we wanted to. So let's do this. Let's say, I'm just trying to remember exactly how to do this here. Yes. So this, we don't want to do this. We want to actually have this not set to relative, I feel like, but setting it to absolute. Okay, enough. Let's do absolute there. And let's do the steps. I don't know. Let's do like every 6 frames or something. And let's just say we're going to go from 1 to 64. And so, yeah, this is a much more logical way of doing this. Also, you'll see that the, we don't have the time dependency anymore on this, which is important. So now you can see I can just scrub this all around, and that's basically what we want. And so here you can see we have a bunch of color outputs, 0 to 10. What we can do is then put these into the contact sheet, wire this in here. And now you can see we can make something like a little sprite sheet out of this if we wanted to for, well, it's going to calculate everything here real quick. There we go. And so there is our explosion, like sprite sheet, for example. And this is obviously every 6 frames. We could do this, every 4 frames instead if we wanted to. And so this is some of the stuff that we were really wanting to get in here. Obviously, this is really helpful for like games workflows and things like that. But this is really the stuff that makes this a lot more effective, right? And so you could do all of this simulation stuff. You could do some stylization on this explosion or on any explosion for that matter, and then get a nice output like this. And yeah, you could use that to input into whatever whatever type of software you're looking to use this for, or yeah, sprite sheets, things like that. Old school, 8-bit looking stuff. You could do all sorts of things. So yeah, this is kind of the idea of that. And obviously anything that you're going to do upstream of this is going to work. The other really neat thing too is if you were going to do stylization of this, I'm just thinking about this as I'm kind of going, but let's look at this here and see if we can find something interesting from like a filter standpoint. Let's see, what could we use? An artistic filter. Maybe we do like a pixelate filter on this or something. What we should be able to do here is plug this in. That's a little unfortunate. I kind of thought that would work. Interesting. Kind of confused by that. So there's those. Let's see. What if we did? There we go. Okay. It just had to update that for whatever reason. So now we can actually do this without having to re-update everything. But this, you know, we could obviously do pixel explosions and things like that. You know, that type of stuff. But that's interesting. So the reason that this is working the way it is, and we're getting this on all of these different images, is that this whenever you have a cable like this, you're able to more or less drop down nodes on it and have it work through them as if it's almost like a for each loop. So that's kind of the one nice thing about this. We could also just do this, just throw a stash in here, just real quick. Just stash the input of that. That should put those images in this stash node, I think. Okay. Yep. And then anything we put in after the fact here should really not recook that at all. But so like if we did a glow, oops, we did a glow on these and go to the contact sheet at the end here, we should be able to get a nice little glow. There we go. We'll really go silly with it. And let's do the pixelate as well. There we go. So we got some pixelated art, whatever. So there we go. A little something just to kind of play around with there, but that's the idea of what you can do with some of these time-based, you know, elements in Copernicus. Obviously a lot you could play around with and do other interesting things there, but yeah. Releasing the Neo Geo this year. Interesting. That's an old one. Boy, that sounds like an old. I can't even remember what that is. That's almost before my time. Okay, cool. So let's look here at let's do some Solar. I can type. All right. So we have the ability now in a lot of tools to kind of change up where the prototypes live for point instancing and things like that. Let's go back in this for a second. All right. So what we can do here is let's touch on a couple things here. First of all, let's do a copy to points. The instancer is now called copy to points, so that's something to keep in mind. So this is our overall general instancing type setup, kind of copying things to points, allows for references and inherits and specializes and all these kind of things, which a lot of these other than instanceable things are actually not instancing. So that's why we changed the name from the instancer to copy to points, because really this is a little bit more along the lines of kind of an all encompassing copy to points node. All right, let's just grab, I don't know, pighead, sure, whatever, something straightforward here. Go inside of here and let's just do a grid with some scattered points. Very straightforward, nothing exciting here. We'll do 100 of these, I guess. And there we go. There's our wonderful pig heads. In fact, I'm going to make even less. We'll do like 25, something like that. Okay. And let's say we wanted to do this, right? And we wanted to do, okay, let's do a few different things here. Let's do another copy to points. And I'm just going to make these all kind of in a network here for us. And so this, we're going to do, oops. So we're going to do the toy, wire that in there, and let's come inside of here and let's do a, let's do another grid, but we're going to do this on the XY plane. We're going to move this back here and up like so. And we're going to scatter onto this. And we're going to do 25 again. Actually, I could probably just copy and paste these. Okay, so there's our rubber toys. And then we'll come down here. And let's do another test geometry. Let's grab the squab. Classic squab. And let's do this. And I'm going to come inside of here. Set this grid to be the YZ plane, and we'll move it over on this side like so. And let's just say you had a few different instancers here like this. Neo Geo was the one that nobody could afford, but was identical to the arcade. That's awesome. Games were oh my gosh, that's crazy. That is fun. Okay, so we've got our different instancers here, right? And let's just, for the sake of some not simplification, but let's organize this a little bit here. We'll do these all to geometry OS like so. Okay, so these are all going into geometry plus the name, and we'll just say pig instances. We'll call this toy instances, and this will be squab instances. Okay, cool. So we've got all these different things, and the prototypes live underneath them, right? And these are just point instancers, right? This is just basically a prim that has a bunch of information on where the point positions are and the orientations and things like that. So everything kind of lives on this one place except the prototypes, right? And the one thing that can kind of get weird about this, right, is you have all these point instancers and you've got all your prototypes, and let's just say you wanted to maybe even reuse some of these instances, right? Well, you kind of, or some of these sources, you kind of can't in some ways. Like you'd have to like sort of re-import them or do some weird stuff to like reference them into different places and stuff like that. So in order to make your the scene graph a little bit neater, what you can do now is you can say, let's see if I can find where this is. There we go. So there is now this destination for the prototypes. And so what we could do instead of having prim path in here is we could just say, let's just put this to /prototypes. And you can see now we have our pig under that prototypes, right? And let's just say we wanted to do this. Actually, you know what? Sorry, let's do this. Let's do geometry /prototypes. Just to make it a little neater. I don't know if I want to have that as a top level primitive. So now we can have geometry prototypes like so. And I'm just going to copy and paste this here. Let's see here. Oh, right. We don't even have to do that. We can just come like this and like this, right? And so sorry, I might have done that incorrectly. What did I do here? Sorry. Interesting. That's weird. I don't. Sorry. What am I? Interesting. I'm not sure why that is. Okay. So I guess that's what we would want to do here. So let's just go through and change these all like this. So for some reason, it's putting those at the same. I'm not sure exactly why. Now, so here is the thing that we're seeing too. Now we need to hide these all, right? So we'd want to probably make the visibility of this invisible. So we could just do configure prim. just make sure that that one is set to visibility, visible. There we go. So now we have a prototype section and an instances section, right? So these now are sort of decoupled from each other, right? And I think actually what we'd want for these is probably a group prim type. Yeah, we would want a group for those. And then that shouldn't be angry about those anymore. Great. And so we have these instances, right? And so what I think we could do now that we have these sort of decoupled like this, it could make it a little bit easier to say, let's say we were going to do another copy to points. And we're going to say we're going to get these from the first input. Oh, okay. Interesting. So it's like an optical illusion, Chris is saying. That's really funny. Huh. Weird. I'm going to try this. I'm going to take this out of here. Actually, it's not going to work for all of them, is it? Oh, yeah, it does work. Yes, it is like an optical illusion almost. Oh, that's weird. Yeah, but I would want them to be organized a little bit better. So that's okay. Very strange, but that works. Cool. Okay, so let's say we wanted to do this and then make a new one, say, call this multi-instance. I think what we could do here is we could say the source. Oh, hello. Interesting. That was weird. That's weird. Okay. Well, looks like that might be a bug, but I'm just going to drag and drop these over here. And then I'm going to do a, let's see, we're going to do a grid. Actually, I'm just going to grab the other stuff from in here. Paste those. And I'm just going to move this grid across. Like so. There we go. All right. And so there we go. So we don't need to create the prototypes area, so we can uncheck that. And then this multi-instance is going to go into this same spot there. And we can see we have a multi-instance of all of those things that we did already. And so now we have all these different things here. And we can kind of play around with them. So it's kind of interesting to be able to make your own prototype section, basically, of your scene graph tree and be able to use that again, if you want to. For example, here we're using it in copy to points, but there's other ways of doing that as well. YouTube, Pizzola is saying, so it's basically just a copy of the asset. I used to do that beforehand, and I would set the assets in folders and with collections and instance from there. Yeah, it's basically just a way to be able to organize it as you're going, basically. So you could have like a specific prototype primitive that things would be stored under, and then you can just keep your point instances, point instancers in one spot like this. You can see these are all obviously point instancers here. And so really all this is just a single prim. There's not really anything extra. And yeah, it keeps your scene graph tree a little bit lighter. Obviously in this case, it's not a big scene, but if you're doing something really, really big, you can imagine how this would be super helpful to not have, multiple prototypes for each, for each different instancer that you're using and prototype things underneath it, all that type of stuff. Let's see. Jack was asking, Do you add materials to your objects in Solaris, or do you not use Karma and add materials in something like Redshift? No, that's not a weird question. I personally haven't used Redshift very much. I was going to get it for doing this stream when I first started it years and years ago. Started working at Side Effects and was like, and actually even before that, I started using Karma and I was like, oh wow, this is like, I feel like this is really working well enough that I don't need to buy a license of Redshift. And then obviously I started working at Side Effects and I'm like, well, I have kind of an obligation to use Karma, but I like it now. So I mainly just use Karma. But you can go either way. I mean, if you're doing rendering and stuff like that in Solaris, you add your materials there. I wouldn't work in Solaris and then go back to the object level. That would be pretty crazy. Yeah, so yeah, let's cool. Yay, I'm right. I got it right. It's my karma to use Karma. Yeah, exactly. Okay, so there's a couple questions coming in here about some other stuff as well. So let's talk a little bit about the point instancers. So there was also a thing about scatter instances there that Ammon was asking. It has a point instancing checkbox. I'm actually not 100% sure what you mean by that, but that's okay. Scatter instances. Let's see here. Oh, point instancers checkbox. That's a little bit different. Peter's usually, wow. No, usually I say if Tom or anybody else from Side Effects is in the chat, you should listen. You should listen to them. That's very kind, Chris. Thank you. So the difference between the point instancer checkbox here is that this is actually using point instancers coming in to set as places to avoid in the instancing, right? So scatter instances is kind of different from copy to points, whereas these have points that we want to scatter onto. Scatter instances is using geometry, right? And so that's a little bit different. So like in this case, we'd use a grid, right? And we'd throw this in here, and I could I'm just going to do something probably a little dumb, but we'll just do this. So all of our prototypes are in there now. So this is all of those prototypes. We're going to scatter them onto this grid, and I haven't told it to scatter onto this mesh yet. Oops, that's not the right thing. Scatter instances. So here's my source geometry. I'm going to scatter to that, and we should be scattering now, although you don't see it. So let's turn on Karma CPU and see if we see it. Give it 1 second to think. Kick off my Karma render. Interesting. Oh, I have like 1,000 instances in here. That might be a little bit much. So what am I doing here? Why are we not getting this? All right, let me just turn this over to immediate mode real quick. So if you're wanting to see it immediately, there you go. Okay. That's really strange. Why were we getting that? Why were we getting that? That's a good question. Okay. Oh, you know what I'm going to do? I'm going to do a match size on this just to move this up to, there we go. Now at least they're all sort of in some logical spot. Okay, why were those not rendering? Okay, so this should definitely render because this is now not the render time instances, but let's change this back to deferred. Maybe because there's no light? Huh. Weird. I was literally just using this a little while ago. It's very strange. Huh. Oh, is it this? No. Oh, it might have been that. Let's go back to CPU. Now labels have notes inside. Oh, they can. Yes. These here, render camera used if blank. Yeah, that's a new thing. I don't know how that works, but yeah, that is kind of a, there we go. Yep, it was probably the point instancer thing. All right, now we kicked it back off and we're good. Okay, so again, just to go back to this, VK should show nothing because we're deferring it to render time. And then when we go to render time, there we go. There are our scattered objects. So this is going to scatter onto objects, which is a little different from scattering to points, basically. And we can do some cool stuff here, like we can change the variation on the spin of these. So now we're going to have all different positions and stuff like that. There we go. There's our karma physical sky. We'll change this up to 1. There we go. Cool. It's a Chris is saying it's a parameter tag on string parameters. You can fill it some hint text if nothing's typed. Ooh, yeah, nice. So it's in, let's see. There was one in here. Edit parameter interface. We go in here and good Lord, I'll never find it. What was the source geometry prim pattern? Let's see where it is. Source geometry prim pattern. There we go. Looks like there's a tag in here that must, yep, prompt text. Cool. There you go. So looks like once the real-time renderer catches up, it's actually really fast. I'm not used to CPU being that fast. Well, it could be my CPU too. Like I've got a decent CPU, so it's fairly quick. It's also, I don't have like any real render settings going on here and there's not a lot happening in the scene. So what's actually happening here, just a little technical stuff, is in this deferred mode, we're actually using this. This is actually a Hydra generative procedural is what it calls. And with that, basically the viewport, like any viewer in here, these are all Hydra delegates. And so there's this extra layer in between what's happening in USD and what's happening in the viewport called Hydra. And so with that in mind, it's actually a procedural that's working in that like in between layer that's kind of happening there, that in between step. And so we're doing a bunch of stuff in Hydra in order to scatter these instances basically. And so that's why we're not seeing them in Vulkan, because this basically must be just told to not show because it is technically a Hydra delegate, but just in order to make this fast, if you were scattering millions of instances, you wouldn't, want that. So like, for example, if we wanted to go back to the default scatter count and let's change the scale of these. Where are they? There it is. Scale. Let's just, I don't know. That seems fine. Yeah, there they are. And so let's scatter these down like so. There we go. Cool. Okay, so we've got a bunch of scatters here. See ya, no dinosaurs. There you go. There's an official answer, Ammon, for that question you had there, scattering animated instances. Yeah, you'd have to, right, like Chris is saying, you'd have to time offset them ahead of time and then put them in. Oh, cool. I was guessing at that, so that's cool. Oh, where can you enable that, Chris? That's interesting. Where can you enable that? Oh, here. Oh, okay. So it must be that you come in here and then you can say that. Then that'll draw the Hydra generative procedural in the viewport. Oh man, I hope I didn't just crash my computer. What did I do? Apparently, I'm just good at guessing things. I'm going to give this a second for it to think about its life, think about all it's done wrong in life, and go from there. Oh, that does work though. Look at that. Look at that. If I change this, is this? Oh, that's really quick. Cool. So yeah, so this is not actual, like, it's not technically a point instancer. It's really weird, but We did it, Chris. We didn't crash my computer. But that's why it's turned off, so you don't crash your computer. So yeah, so cool. That is just a little scatter instances stuff there. There's lots to this, so I don't want to like go too far into that. I'm actually going to be releasing a little video on that as well, not too long from now. So keep an eye out for that as well. Cool. Now the point instancer thing was something that people were asking about. And I'm going to copy and paste. Well, no, it doesn't really. Well, it doesn't really matter. Be pretty quick. All right, so let me do a LOP network here. And let's call this Solaris. And yes, point instancers are all one word. Chris has made that abundantly clear to me, even though it feels really bizarre to me. It is all one word in USD. There's a couple things in here. Sorry, I came late. Question burning under my nails. Is any Geo super faceted in the Vulkan Solaris viewport? Oh, why is it super faceted in the Vulkan viewport? I haven't run into that. I don't know. I've never run into that. Gemabaris. I have not run into that. I was using it a little earlier and I didn't see any faceting in there. Oh, when I demoed it earlier? Oh, really? It's faceted? Where are we seeing the facets? Oh, yeah. I think that might be something from the preview surface, possibly, because it's not in here, right? So that might be something weird going on with like the preview surface. I think that might be what's happening there, because yeah, I have a oh, there we go. There's a good answer. So it has the okay, that's why. Okay, interesting. Because it has it set, it does some faceting to it. Okay, there you go. Yeah, so it's just a viewport thing. It's just a Vulkan viewport thing. It's not an actual like renderable issue. Why is this erroring? What is this unhappy about? Oh. Sorry. Disabled displacement with the geo properties though, and it's still there. Yeah, it probably doesn't really matter if it's in the viewport though. Like, because if you're not seeing it in the oh, okay. There you go. So that would be probably in here. Well, careful with that, because apparently I just did something. Just turned off displacement map here. Not happy. Hey, there we go. We're back to something. All right, what do we got here? Still faceted here. What am I? Yeah, interesting. Also, why is this not like... Weird. Oh, it's an instance proxy primitive. Can't do that. Weird. I don't know what's going on here. Well, I apparently have destroyed something here and it will not work anymore. But anyways, all right, we're going to move on to the point instancer thing. But yes. Yeah, let's talk about the point instancers because I think that's a really cool update here. So what we can do here, let's do the same thing. And we actually now have a point instancer node, right? And so this should be able to do pretty much, pretty much everything you'd want it to do. And I think you don't even have to use modify point instancers anymore. And so let's do this. Let's just grab our different geometries here. So we'll grab our pig and we're going to do grid with a scatter. Basically the same thing we were doing before. Except with this, I'm going to make it, let's try it at like 100, like so. We'll do a few thousand instances in here. Okay, so we'll do that, put this into the output. You can see an interesting little note in here that there's this existing point instancers, which we don't have right now. But there we go. Now we've got all of our pig heads in here. And let's just kind of copy and paste this a couple times here. So we'll do this, and we'll do toy. And wire this together like so. And let's just change the global seed on this. We'll change it to something like that. All right, so let's move this back and up. Yeah, I moved it a little too far. That's okay. Probably put this around 50. That's fine. So we're just going to do the same, roughly the same thing we did last time, just with a little slight difference. There we go. Okie doke. And let's see, we'll say pig instances, toy instances. It's going to be the same, similar setup to what we did before. And then let's do the squab. Like this. All right. Change the seed. Change the thing here. And then let's move this over. And we can set this to be about in the middle. Like so. Okay, so there we go. There's all of our instances, right? And so this will be squab. Okay, and I am going to change like so. Just copy these over. There we go. Okay, so now we should have these all in their little spot here. And so what we can do is we're going to do another point instancer node here. Or is it, sorry, is it edit point instancer? Is that the right one for this? Yes. So if we do the point instancer node, it's going to, here, let's just look at the difference between this. What's changing here. So here you can see we're creating an empty point instancer. We don't have anything in the existing point instancers, and we're basically just kind of starting from scratch. With the edit version of it, the edit point instancer, we've turned off this create empty point instancer, and now we're looking at all the input prims that are of type point instancer. So this is just a little primitive matching pattern that's basically just saying, give us the point instancers here. So now if we wire this in, this should now wait a second. Why is that happening? Okay, interesting. Well, that's okay. Basically what it was saying is there is nothing coming into the second, so that's fine. Now if we come in here, we can see that our existing point instancers is connected into the output, and we have all of these points in here that are representing all of these point instancers, right? And so what we could do is we could do any number of things. We could, let's see, we could just do a, let's see here. Let's just, oops, my bad. Actually, I'm going to delete this too. So let's say we're going to go in and edit some of these points, right? So let's do S2, and let's just use the, sorry, I'm learning these again, brush. And let's make this a little bigger, and let's just kind of make a brush of a bunch of points here. There we go. And let's just take, oops. So we're going to do S. Yeah, let me hit every button. S2, do this, edit. Let's just do a transform. What? Oh, okay. That's weird. Sorry. Let's try this again. S2, brush, transform. Ooh, that's not right. Okay. Well, that's an interesting bug. Okay, let's just draw like that. There we go. And let's do move pivot to centroid, and I'm just going to like rotate these all like this. Something like that. Okay. And so now we've got these output. And so what should happen is we should have those exactly move as we'd expect there. So now all of those point instances were able to be edited by this one node here. And we could actually like move these over like so or something. I don't know, whatever. So that works like that. Now the other thing, interestingly here, I think we could do is we could do this. Yep. Now, can we actually, can we see that in the viewport? No, because it's a viewport interaction, but we can actually see these move here. So that's kind of interesting. We can actually, you know, edit these with that little viewport thing. And so now here, these are all, you know, we can kind of see these move around like this. And so when you're editing these, you can now just go in here, make point edits, and just edit away to your heart's content. And basically, oh, interesting. Weird. Okay. So anyways, so yeah, the question here is the modify point instancer is outdated now. Yes. Yes. That's kind of a deprecated workflow now. I mean, it still exists, but this is definitely the faster way of doing it. And there's some really interesting things happening here as well. I'm going to uncheck this. We're basically keeping track of, you know, obviously where these are coming from and all that kind of stuff, their paths, their IDs, things like that. And that's allowing us to be able to kind of sparsely edit these, right? And then put them back into their places. The other thing you could do too is you could add remember using this as the copy to point star. Yeah. That might still be valid for other workflows. I can't exactly remember. Yeah, like Chris is saying there, definitely log a bug if you're having trouble with that. That definitely is the right way to go, because it does seem like it should be resetting, but sometimes it's a little viewport thing or whatever, some sort of little bug in there still. Okay, so anyways, yes, I think that the copy to points with the star at the end of it is still a valid thing in some places. It just depends on what the workflow is. But here we're actually kind of parsing all of this information together, and there is actually a way to control these a little bit. There are these edit modes and things like that. So you can actually sparsely edit them, which basically means you're just making edits to just the points that you're moving or whatever. So you're just basically making these kind of these edits to the points that you're specifying here, basically. And so we could just say edit point instance, something like that. And I see. Yeah. So Chris is saying that the modify point instances edits them as packed prims. So that's going to be a lot heavier versus just individual points. So it's a much lighter workflow overall. And there are actually ways to add into these as well. I think, if I'm remembering correctly, my PC was exploding to the pack workflow. Yeah, exactly. If I'm remembering correctly, you could come in here and let's see. I'd have to think about how to do this actually, because I feel like if you add points in here, it's going to do something. Let me just add another grid with a scatter, and then I'm just going to merge them in, just see what happens. I don't remember what happens with this. Actually, let me just move this over and do 100 by 100. Just move this way over here, something like that. Let's see what that does. Yep, doesn't do anything because it doesn't know what it is. Yeah. So basically what you need to do in order for this to actually work, I think, is you need to put in IDs and the paths to the place, like to what they are, right? So like, for example, here, let me copy this text. Let me just see if I can add a path onto these. Just do a name edit here, and we'll say path, and let's do that. We'll put this on the points. How did I make it so fast? Chris is asking me, how did I make that merge so fast? Yeah, it's you click each thing, you shift click them, and then alt click, and it makes a merge. It does that in LOPS too, I think. I think it does it in every context. So if you do that and then click, there you go, get a merge. Also, there's a new icon for merge, I think. I feel like it is, at least. It's cool. I like it. And I like that it's different than the merge one in here. So yeah, anyways, there you go. There's the content. So this did actually work. So what I did is I took the toy instances and I put the paths here on these. So what I could actually do is oh yeah, there's some crazy stuff you could do with this then. So like here, I'm just adding these extra points into here, and now it obviously puts all of these toy instances down here. But what I could do is I could come in here, and instead of this, I could say attribute randomize, and I could say What is it? What is it? What is it? There we go. It's this. It's this. That's what it is. Okay. And then I can grab these string paths basically. So I could just say this and then copy this a couple times and I could just rename these squab. Yeah, it's a good one. That's a good little speed up there. Okay, so that should work. And this is going to be on path. And if I wire this in, yeah, there we go. So now we're getting those. That seems right. Let's wire that in there. And if we come back up here, there we go. So now I've just added a bunch more points into those instancers here. And those have actually now been specifically put into those point instancers. So like, this is not like a new instancer. This is actually added instance. You can see there, I can select that and it's actually going to select that instancer. So there's some really cool, weird workflows that you can do here with this point instancing thing where it's a little bit of a different workflow. And that's why this node exists and is very cool. So it's a good new workflow here. There's a couple things. It's 8:15, so I'm going to be wrapping things up here. But there's a couple more things for me just to shout out that I was going to go into, but just I guess isn't time. So one of them was npm height field. So now you can use height fields with npm. So you can use it as a collider. So that's kind of cool. There are global AOVs now. So if you come into like if you go into Solaris, yeah, I'll just do it in here real quick. If we do a test scene for the, I don't know, the noise sampler, sure, and use that, load that up. There we go. And then if we do karma, what we can actually get in here now, okay, thank you. I forgot there's two of those now that come in. We can actually come in here and go to image output. And there's actually this global AOV material now. And so you can actually set this up. And if you come in here and take a look at this, this is actually now made a node in here that actually this is actually going to be your global AOV material. So you can do some, like you can make an AOV and actually apply it to every object in your scene basically with that. So it's kind of like a global AOV override. And there's a nice little button there for it with a cool little paint roller, which is kind of fun. So that's a cool new one. And there's also the image filter lop now. So this is basically like a, let's see here. I could probably, oh, this actually has everything in it. No, it doesn't have the render in it. So let me do this. And this should actually allow for me to add some stuff in here. And we should be able to go into something like karma and see this, I think. Maybe. Do we need to go through the camera? Oh, I need to turn it on, right? Where is it? Yep. Oh, no, it's not like a clay render that you would use, unfortunately. That would be like a global material override kind of a thing. Although I feel like there's a way you can do that. But yeah, why is this not working? Why am I not, do I not have this on enough or something? Weird. Huh. I thought that would work. Well, take a look at this. It's in here somewhere. I'm not sure why it's not working, but yeah, take a look at the image filters. Probably I'm just doing one dumb thing that's not making that work. But anyways, there's a couple Drag the image filter into the render pass. Okay, maybe I just didn't assign it properly. So yeah, play around with those. Those are some fun ones that are in there now as well. So yeah, that is, I think that's where we're gonna end things up this time. Yes, you can also create one from the viewport, but that one is actually one that would live within Solaris. I think that's actually making an image filter primitive that lives in your scene. I think, yeah, here, there's image filters in here. See you, Chris. Yeah, me too. I'm running as well. My kids are not back from swimming, but I'm ready to be done. So, yeah, that's the difference between this and the viewport one. This actually is a USD specific thing that you can actually write in there. So, that is, oh, sorry, I stopped sharing my screen, but you know what I'm saying. Anyways, cool. So that is some of the features that I thought were pretty interesting from this. Also, thanks to Brian, one of the other tech consultants at Side Effects, that we were chatting today, and I was like, what do you think are some good ones? So he gave me a couple of those as suggestions. And so those are some good ones. There's also a new thing in USD if you're a big fan of crazy USD stuff. The relocates a composition arc is finally now has a node as well. That is way too complicated probably for me to even get into or start making people think about, but it is there if you want to use it. You probably shouldn't, I think, but it's there if you need it. So yeah, so that relocates is one of the new additions to the liver peas thing. And if you have no idea what I'm talking about, don't worry about it. All right. So that is where we'll end it for today. Thank you all for being here and for chatting. Super huge thanks to Chris for coming into the chat and just helping answer some questions. That was very nice. And yeah, thanks to everybody for just for the questions and all the good chat. And that's it. That'll be where we ended it today. So thank you everybody for being here. Thanks for the great conversation, and hope to see you next time. So until then, not next week, there won't be a stream, but it should be the week after that. So if you have suggestions for streams, feel free to drop those in the Discord server, and maybe we'll get to one of them when we get back. So thanks everybody. Have a great rest of your day, and see you later. Bye everybody.